Yesterday you worked with translations and reflections. Today you're going to work with stretches and compressions. So still about location, 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 and operation, operation, operation. So let's talk about what a stretch is. A stretch is a pull of all the points of a function away from the x-axis or the y-axis. So just kind of think of it like this. You're taking a function and you're stretching it this way, or you're stretching it this way. So it's pulling away from the x or the y-axis. Now a compression on the other side is and we need to change this to push all of the points of a function towards the x-axis or the y-axis. So compression, we're going to go like this. We're pushing all the points together this way, or we're pushing all the points together this way, horizontally or vertically. All right, so when we have a stretch, we multiply. So yesterday was a translation, so we added and subtracted. And reflection, so we took the opposite. Today is multiplying because it's a stretch or compression. Okay, we're going to use the same function to start with as we did yesterday. F of x equals 3x squared. And we want to describe what transformation is taking place. So again, I'm going to highlight anything that's not 3x squared. Since it's not in the horizontal house, I know that it has to be vertical. Since this number is larger than 1, just like back in chapter 1, it's going to be a stretch. And then we just have to say by a factor of 2. Okay, now we have to address the horizontal. Horizontal stretches and compressions do not, so again, circle, highlight, underline, star, whatever you want to do to help yourself remember that horizontal stretches and compressions behave differently on functions than they did with points. Okay, now yesterday you took the opposite inside the horizontal house when you were adding and subtracting. When you're stretching or compressing, you take the reciprocal. So before you decide if this is a stretch or a compression, you have to take the reciprocal. So we know that it's inside, and this is the transformation that's taking place, the 1/2. So we're going to do, if it says 1/2, but because it's in the horizontal house, we have to think 2. Okay, so that's the number that we look at to decide if it's a stretch or compression. Again, inside the horizontal house, so that's horizontal. Because it's larger than 1, it's a stretch by a factor of 2. Okay, now we're going to identify compressions. Compressions, you're also going to multiply, but the number is going to be between 0 and 1. Now, I don't want to say less than 1 because then you get into the negative numbers, and the negatives or opposites mean that it's a reflection. So let's go ahead, and we have 3x squared, so we're going to highlight this 1/2 here, and we're going to highlight the 2 here. Okay, so now this is not in the horizontal house. So if it's not in the horizontal house, which has the x inside, then it has to be vertical. The number is in between 0 and 1, so that means it's going to be a compression. And then we just say by a factor of 1/2. Now we're in the horizontal house, and we have the number 2. So because we're in the horizontal house, we have to take the reciprocal, which means we need to think 1/2. So it's between 0 and 1, so it's going to be a horizontal compression by a factor of 1/2. Okay, now we're going to do the same thing as we did yesterday. Now we're going to write a rule given a transformation. So we're starting out with this being our original function. So now we're going to write g of x equals, and this is a vertical stretch. Remember, vertical is the y, so it affects the entire side. So we're going to put this in parentheses, and we're going to multiply it by a factor of 4. So 4 times 2x plus 3. Our new function is g of x equals 8x plus 12. Okay, now watch out. We have a horizontal, so it's all about location, 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 and operation, operation, operation. So we're going to do g of x equals 2, and because it's horizontal, the x goes inside the horizontal house. It's a compression by a factor of, this should say 1/3, so let's change that, factor of 1/3. So when we substitute that back in here, we have to take the reciprocal. So this is going to be, the reciprocal of that's going to be 3. And then we have the plus 3 at the end. So if we simplify that, it's going to be g of x equals 6x plus 3. Okay, now we have a horizontal stretch by a factor of 5. So again, horizontal goes inside the horizontal house. We write the function. Whoops, let me bring the function back down here. We write the function, and as soon as I get to the x, I pop that in the horizontal house. And it's a horizontal stretch by a factor of 5, but when it goes inside that horizontal house, it becomes 1/5. And then that's the only thing that goes in there, the x and the transformation, and then we say plus 3. So now if we simplify that, g of x equals 2 times 1, just like 2 over 1, we multiply straight across. So this is going to be 2 over 5x plus 3. Okay, last one is a vertical stretch by a factor of 3. So vertical means the entire side. So you either have just the x or the entire side. So g of x equals 3, and again, put parentheses. So this is going to be g of x equals 6x plus 9. Okay, you have a few questions to try on the other page.